This is question number 10 of 1000. So today, let's find the Maclaurin series for cos of x. Maclaurin series is basically a Taylor series centered at 0. So the general formula of a Maclaurin series is given as f of x equals to summation of n from 0 to infinity of nth derivative computed at 0 times x to the power of n over n factorial. So if we expand it out, we get that f of x is equal to f of 0 times x to the power of 0 over 0 factorial, which is just f to the 0 as x to the power of 0 is 1 and 0 factorial is also 1, plus the first derivative computed at 0 times x over 1 factorial plus the second derivative computed as 0 times x squared over 2 factorial and so on till infinity. So since we're finding the Maclaurin series of cos of x, let's change the f of x as cos of x. So when n is 0, we just have cos of x. Derivative of cos of x is negative sine of x. Derivative of negative sine of x is negative cos of x. Derivative of negative cos of x is sine of x, and derivative of sine of x is cos of x. So if we compute all these values at 0, cos of 0 gives us 1, sine of 0 is 0, negative cos of 0 is negative 1, sine of 0 is 0 again, cos of 0 is 1. So this tells us that all the odd values for n are 0 and all the even values are alternating signs from 1, negative 1 to 1, and the next value, which is n equals to 6, should have negative 1. So we plug these values back in the expanded form of Maclaurin series, we get 1 plus 0 times x over 1 factorial, which is 0, plus negative 1 times x squared over 2 factorial, plus 0 times x to the power of 3 over 3 factorial, which is also 0. So all the odd terms are 0 and we only have the even terms. So with that, we get that cos of x is equals to 1 plus negative 1 times x squared over 2 factorial plus 1 times x to the power of 4 over 4 factorial plus negative 1 times x to the power of 6 over 6 factorial and so on till infinity. So we can write this as a summation and we get that it's a summation from n equals to 0 till infinity. And since we have alternating signs for 1, we get negative 1 to the power of n, and all the x's have twice the power as n. So at n equals to 0, we have 0. At n equals to 1, we have x squared. At n equals to 2, we have x to the power of 4. At 3, we have 6. That means we have x to the power of 2n. And same thing with the factorials. They are twice as our n, which is 2n factorial.